Hi everyone! Today we're going to be talking about a concept called completing the square. Our objectives for today are that students will be able to solve quadratic equations by completing the square. Let's get started. Alright, so if we have quadratics that are perfect square trinomials, it's extremely easy for us to solve. All we do is first factor the trinomial and then use the square root property. So for example, number 1, x squared plus 14x plus 49 is what we would call a perfect square trinomial. Because when we go to factor it, we do our diamond, put 49 on top, 14 on the bottom. We know that 7 times 7 is going to multiply to 49, and 7 plus 7 gives us 14. So our factors are x plus 7 and x plus 7. Set this equal to 4. Now we can rewrite this as x plus 7 squared equals 4. Now what we want to do is take the square root of both sides. So we're going to be solving this by the square root property because we're taking the square root of both sides. So the square root eliminates the squared, so we end up with x plus 7 equals plus or minus 2, because the square root of 4 gives us 2, and we can't forget to put the plus or minus before it. Then we just subtract 7 from both sides, and we get that our solution is that x equals negative 7 plus or minus 2. So we want to break this down into two separate expressions. We say negative 7 plus 2 and negative 7 minus 2, because that's what the plus or minus symbol means. Alright, so then we solve both of those separately, and we get negative 5 and negative 9. So those are both of our solutions. Now we want to write it in a solution set, so we say x equals negative 9 and negative 5, because we always put it in order from least to greatest. And we're done. Alright, number 2 is just a little bit more challenging, but it's the same concepts. It's a perfect square trinomial, so what we want to do is first factor. So 9 goes on top, negative 6 on the bottom. Two numbers that multiply to 9 add up to negative 6 would be negative 3 and negative 3. So we write our factors. X minus 3 times x minus 3 equals 20. We can rewrite the left side as x minus 3 squared. And then using the square root property, we want to take the square root of both sides. So we get that x minus 3 equals plus or minus the square root of 20. Now we want to simplify the square root of 20. We can break this down to be the square root of 4 times the square root of 5. We can take the square root of 4 and we get 2. So we know this equals plus or minus 2 rad 5. And we know x minus 3 equals this. So then we want to keep solving. We want to add 3 to both sides. Cancels out. We end up with x equals, and we always want to put this plus 3 in the front. We want to put it before the plus or minus sign. So we say 3 plus or minus 2 rad 5. We put it in a solution set, and there's our answer. Alright, so if we have a perfect square trinomial, and this right here is a perfect square trinomial, all we do is factor, simplify, take the square root of both sides, and write our final answer in simplest radical form. Now, it's possible to make any quadratic equation, create a perfect square trinomial, and solve it in this same way where we factor and use the square root property. And this method is called completing the square, all right, when we turn any quadratic equation into a perfect square trinomial. So what we do in order to complete the square, the first thing we want to do is rewrite our equation as ax squared plus bx equals c. Then if we have an a, we want to divide both sides by that a. So it just becomes x squared plus bx equals c. Then you want to complete the square. All right, this is a new concept. We complete the square by taking half of b, squaring it, and adding it to both sides of the equation. Then we want to continue factoring the perfect square trinomial, so then we're solving just like those warm-up problems, numbers 1 and 2. Take the square root of both sides, create two cases, because if you have a square root, you have to remember it's positive and negative values, so you can't forget to put the plus or minus symbol. Solve both equations and always simplify your irrational numbers, complex answers, always put them in simplest radical form. Alright, so let's go through a couple examples of this. All right, number 3. Number 3 is an example of a problem that we can solve by completing the square. First thing we want to do is make it in the form ax squared plus bx equals c. So we want to subtract, oops, don't want my highlighter, I want my pen. Subtract 56 from both sides. We end up with x squared minus 18x, and I always leave a space here, equals negative 56. And you'll see why in a minute, why we leave a space there. Then, in order to complete the square, so this is step number 3, you want to take your b, which is, in this case, negative 18. So we take our b and we divide it by 2, and then we're going to square it. All right, so we take our b, which is negative 18, divided by 2, and we get negative 9. Then we want to square negative 9, and we get positive 81. Now, what we get here, positive 81, is what we're going to add to both sides of the equation. So that's why I left a space. So we remember we're adding 81 to this side, and we have to add 81 to this side. Now, we're looking at this right here, and this is a perfect square trinomial. So then we want to factor this perfect square trinomial. So if we're trying to factor this, we look for two numbers that add up to positive 81, or multiply to positive 81 and add up to negative 18. So that would be negative 9 and negative 9. So we write these out as factors, x minus 9, x minus 9, and then we want to simplify the right side of the equation. So negative 56 plus 81 is going to give us 25. Then we want to rewrite x minus 9 times x minus 9 as x minus 9 squared. Then we want to continue solving. Now we can use the square root property, so take the square root of both sides, and we end up with x minus 9 equals the square root of 25, which would be 5, and we say plus or minus 5. Then add 9 to both sides, cancels out over here. X equals 9 plus or minus 5. Now that's not our solution because we can keep simplifying this. What we would want to do is make two separate expressions. We would say 9 plus 5 and 9 minus 5. 9 plus 5 is going to give us 14. 9 minus 5 gives us 4. So our solution to this problem is x equals 4 and 14. And you're done. If you have any questions on this, please call me over so I can help you. Otherwise, let's keep going. All right, number 5. Number 5 is already written in the form ax squared plus bx equals c. So we can skip step number 1. Then the next thing we need to do is get it in the form just x squared plus bx equals c. So if we have an a, what we need to do is divide everything by a. That way, the a goes away. So we divide both sides of the equation by a. So 4 divided by 4 gives us 1. So we get x squared. Negative 8 divided by 4 gives us negative 2 equals negative 3/4. All right, now don't let this problem intimidate you. I know we have fractions, but it will be okay. All right, and I actually forgot to give myself that space. Remember, we always want to give ourselves a space here because we're completing the square. So we have room to add what we're going to add to both sides. Now, complete the square. So we want to look at our b. Our b is negative 2. We want to say negative 2. We want to divide it by 2, cut it in half, and then square it. So negative 2 divided by 2 gives us negative 1. Negative 1 squared gives us positive 1. So we're going to be adding 1 to both sides. Then we want to look at our perfect square trinomial, and we want to factor it. We want to ask ourselves, what are two numbers that multiply to 1 and add up to negative 2? And that would be negative 1 and negative 1. So we get x minus 1 times x minus 1 equals, and we want to simplify the right side. So negative 3/4 plus 4 over 4, because that's what 1 is equivalent to, is going to equal positive 1/4. Then we want to rewrite x minus 1 times x minus 1 as x minus 1 squared. And now we want to solve by the square root property, so we take the square root of both sides. We end up with x minus 1 equals plus or minus the square root of 1 over the square root of 4. Remember, if we're taking the square root of a fraction, we can break it apart. So x minus 1 equals plus or minus 1/2. Then We add 1 to both sides, and remember we always put it in the front. We put it before the plus or minus sign. So we say x equals 1 plus or minus 1/2. And then we want to make 2 separate equations for this, 2 separate expressions. So 1 plus 1/2 and 1 minus 1/2. 1 plus 1/2 equals 3/2 or 1.5. 1 minus 1/2 equals 1/2. So our solutions to this problem are x equals braces 1/2 and 3/2. If you have any questions, call me over. Otherwise, let's do a couple more examples. Alright, so I want you guys to try number 7 on your own. First, turn this into a perfect square trinomial by completing the square, and then solve by using the square root property. Alright, give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now and give this one a try. Just a little hint in case you didn't get this far. Remember, you have to make it x squared plus bx equals c. So you have to add 21 to both sides before you complete the square. Alright, so make sure you got this step and then keep going. When you come back, I'll have the answer written on your screen all the way this time and we'll go through it together. So go ahead and pause your video now. Alright, so you should have gotten that x equals -8 plus or minus 4 rad 5. Alright, and if we have a radical, we just leave it like this. We don't need to break it up to 8 plus 4 rad 5, 8 minus 4 rad 5. Alright, we want to leave it as a radical. Don't try to turn it into an ugly decimal and round. Alright, you can just leave your answer like this. So how did we get here? So first thing we needed to do, and I gave you this little hint, was add 21 to both sides. Alright, then we turned it into x squared plus bx equals c. Then we want to complete the square by taking our b, dividing it by 2, and squaring it. So 16 divided by 2 gives us 8. 8 squared gives us 64. So we're going to add 64 to both sides of the equation. Now we've got a perfect square trinomial here, so we want to factor it. Two numbers that multiply to 64 and add up to 16 would be 8 and 8. So our two factors are x plus 8 and x plus 8, which we can rewrite as x plus 8 squared. We know this equals 80 because we simplify this side. 16 plus 64 gives us 80. Then we want to take the square root of both sides, and we end up with x plus 8 equals plus or minus the square root of 80, and we want to simplify this radical. So we want to look for two factors of 80 that, and which one of them is a perfect square. So we list out all the factors of 80, and we know 4 is a perfect square, but we want the biggest perfect square, because otherwise we got to keep going, we got to simplify again. So we look for the biggest perfect square. We know 16 and 5. Take the square root of 16. 4 goes on the outside. We leave the rad 5 as it is. Then we want to subtract 8 from both sides, and we always put this number in front before the plus or minus symbol. So we end up with -8 plus or minus 4 rad 5. And since we have a radical, we leave it just like this. You don't need two ugly decimals. All right, that would be your final answer. If you have any questions on this, call me over. Otherwise, let's move on to our final example. All right, number 9. I want to do number 9 with you because, just hint, hint, we're going to get an imaginary number as our answer. So since this one's a little bit different, I want to be sure to go through this with you. So first thing we need to do is get it in the form x squared plus bx equals c. So we would subtract 43 from both sides. We want to get the constant to the other side. Cancels out over here. We're left with x squared plus 12x. We leave a space equals -43. Now we want to complete the square, so we take our b, which is 12, divided by 2, and square it. So 6 squared gives us 36. So we're going to be adding 36 to both sides of the equation. Now we look at our perfect square trinomial on the left side of the equal sign. We want two numbers that multiply to 36, add up to 12, 6 and 6, x plus 6, and x plus 6. We simplify this side. -43 plus 36 is going to give us -7. We rewrite this as x plus 6 squared equals -7. Now we continue solving. Oops. Trying to get some more space here. We continue solving, and we take the square root of both sides. Now we're taking the square root of a negative number. So this is why we're going to end up with imaginary numbers. So we're taking the square root of -7. Now, anytime we're taking the square root of a negative number, now we know about imaginary numbers, so we can break this apart. We can break it apart to the square root of negative 1 times the square root of 7. And we know the square root of negative 1 equals I. So we put an I on the outside. And we cannot forget about that plus or minus symbol. So we've got plus or minus I rad 7 equals x plus 6. Now we want to subtract 6 from both sides. Cancels out over here. And you're left with x equals, we always put the negative 6 first, whatever we moved over, plus or minus I rad 7. All right, so we can have imaginary numbers in our solution anytime we're taking the square root of a negative number. All right, so I hope you learned a thing or two about completing the square and solving quadratics by completing the square. If you have any questions, call me over. Otherwise, look to the board to see what to do next, and I hope that you have a great day.